Hi friends, today I am giving a lecture on how to perform the insert operation on a B plus tree with order is equal to 5. In the previous video, we are already discussed about how to perform insert operation on a B plus tree of order 3 and 4. Now in this video, how to perform the insert operation on a B plus tree order 5 that can be discussed in this video. Okay, so this is the given problem. Construct B plus tree for the following elements with the order is equal to 5, 40, 30, 20, 10, 15, 16, 17, 8, 4 and 5. Now, so whenever the B plus tree order is equal to 5, it must satisfy these 4 properties. First one is maximum number of keys per node is equal to m minus 1, that is m value 5, 5 minus 1, that is equal to 4. Minimum number of key elements per node is equal to m by 2 minus 1. Here m by 2 is nothing but ceiling value. So 5 by 2, that is 2.5, 2.5 ceiling is 3, 3 minus 1, that is equal to 2. Next, third property, maximum number of pointers or childrens per node is equal to m. Here m value is equal to 5. Next, minimum number of childrens per node is equal to ceiling of m by 2. So m value is equal to 5, 5 by 2, that is 2.5, 2.5 ceiling is equal to 3. Okay, now while constructing B plus tree, this rule is followed. Suppose this is a node, this node contains k key element. Okay, so this line represents the left pointer. The left pointer points to a left subtree that contains all the key elements less than k, and this line represents the right pointer. The right pointer points to a right subtree that contains all the key elements greater than k. So this is the notation we have to follow while constructing B plus tree. Okay, next. So first we have to insert element 40. Before inserting element 40, so initially B plus tree is empty. So there are no nodes are there in the B plus tree. Whatever the first node that is inserted into the B plus tree, that node becomes the root node, that node becomes the first node, that node becomes the leaf node. Okay, so for that one, we have to create a node and inserting the key element value 40 into this node. Now it becomes the B plus tree. It contains a node. That node contains the key element 40. Now it becomes the root node, and it is also a leaf node, and it is also a first node. Okay, next insert 30. Okay, so element 30 can also be inserted into the same node or not. Okay, so because the maximum number of key elements per node is equal to 4. That means in a single node, we are inserting 4 key elements into that node. Already this node contains only a single key element. So there is a possibility of inserting second key element into that node. Now 30 can be inserted before the 40 or after the 40. So for that one, 30 is compared with the 40. 30 is less than 40. So that 30 can be inserted before 40 in the same node. Because all the key elements in a node, so for example, this is K1 key element, this is K2 element, K1 less than K2. Suppose another element is there, K3, another element is K4. The relation between the key elements in the same node is K1 less than K2 less than K3 less than K4 less than K suffix m minus 1. This rule we have to follow. So after inserting 30, this is the resultant B plus tree that contains a node that contains two key elements 30 and 40. Next we have to insert 20. So before insert 20, so the existing B plus tree contains a node and it contains two key elements, that is 30 and 40. Okay, so first we have to insert 20 into this node. First we have to find out the location where we are inserting 20. So first 20 is compared with 30. So 20 is less than 30, so that 20 can be inserted before 30 because 20 is less than 30. Now this 20 and this 20 key element can be inserted into the same node or not. So in the B plus tree of order M is equal to 5, maximum number of key elements for a node is equal to 4. So after inserting 20, so this node contains 3 key elements, so 20 can be inserted into the same node before 30. So now after inserting 20, this is the resultant B plus tree. Okay, next insert 10. So before inserting 10, the existing B plus tree contains a node. It contains the key elements 20, 30 and 40. Okay, now first we have to find out the location where we are inserting 10. So we have to compare the key elements in the node. So 10 is compared with the 20, 10 is less than 20. Okay, so now 10 can be inserted before 20. So now 10 can be inserted into the same node or not. So in the B plus tree of order M is equal to 5, maximum number of key elements for a node is equal to 4. So before inserting 10, this node contains 3 key elements. Now 10 also can be inserted into the same node. So 10 is compared with 20, 10 is less than 20. Now 10 can be inserted before 20 or left of 20. So now after inserting 10, so this is the resultant B plus tree. Okay, next we have to insert 15. So before inserting 15, so the existing B plus tree contains a node that contains 4 key elements 10, 20, 30 and 40. Okay, now insert 15. So first 15 is compared with this node. This node contains 4 key elements. So 15 can be compared with the first key element. It is greater. Next we have to compare 15 with the second key element. So that is 20. 15 is compared with the 20. So 15 is less than 20. So that 15 can be inserted to the right of 10 and the left of 20. That is in between 10 and 20. So key element 15 can be inserted. So in this place we have to insert 15. Okay. So suppose we are inserting this 15 in this place. The node becomes 10, 15, 20, 30 and 40. Okay. So now this node contains 5 key elements. It violates the property 1. Maximum number of key elements per node is equal to 4, but this node contains 5 key elements. So that to convert this invalid node into valid node, we have to perform the splitting operation. The splitting operation can be performed at the middle element. So how many number of elements are there? 5 elements are there. Now 5 by 2, middle element 5 by 2, that is 2.5. So 2.5 is nothing but ceiling of 2.5 is a 3. So at the middle element is third element. Third element is 20. Now 20 can be taken as parent. So splitting can be performed at node 20, at key element 20. Now 20 can be taken as parent. So 20 can be taken as parent. 20 left child is 10 and 15. 10 and 15. And 20 right child is 30 and 40. 30 and 40. So in addition to that one 30 and 40, 20 can also be stored. Because, so in the B plus tree, so the internal node means a node which has children. Okay, so that internal node contains only pointers or addresses. So these pointer points to the data element at the leaf node. So here this is the data element. So this is the address of data element 20. Now this address points to the data element at the leaf node. Okay. So now these leaf nodes are linked to each other. Okay. So now after inserting 15, so this is the B plus tree we are getting. Okay. Next we are inserting 16. So before inserting 16, the existing B plus tree is 20. 20 left child is 10 and 15. And 20 right child is 20, 30 and 40. Okay. Now inserting 16 into this existing B plus tree. First, we have to find out the location of where we are inserting element 16. So 16 is compared with the 20. So 16 is less than 20. So go to the left pointer. This is the left pointer of 20 and this is the right pointer of 20. So 16 is compared with the 20. It is a lesser. Go to the left pointer. The left pointer points to a left subtree. So the left subtree contains a node. That node contains two key elements 10 and 15. First 16 is compared with the 10. It is greater. Now 16 is compared with the second key element 15. It is also greater. So now 16 can be inserted into the same node or not. The maximum number of key elements for a node in the B plus tree of order 5 is 4. But this node contains only 2 key elements. So 16 can be inserted into that same node. So 16 can be inserted to the right of 15 because 16 is greater than 15. So 16 can be inserted to the right of 15. Okay. So now after inserting 16, so this is the B plus tree we are getting. Okay. So next we are inserting 17. So before inserting 17, the existing B plus tree is so 10, 15, 16, so 20, 30 and 40. Okay. So now, so first we have to find out the location of 17 where we are inserting. So 17 is compared with the 20. So 17 is compared with the 20. 17 is less than 20. So go to the left pointer of 20. The left pointer points to a left subtree. That left subtree contains a node that contains 3 key elements, that is 10, 15, 16. Now 17 is compared with the 10. It is a greater. Next 17 is compared with the 15. It is a greater. 17 is compared with the 16. It is greater. So now 17 can be inserted to the right of 16. Now 17 can be inserted into the same node or not. So every node in B plus tree of order 5 contains 4 key elements. So before inserting 7, this node contains 3 key elements. So there is a possibility of inserting 17 into that same node. Okay. So now after inserting 17, this node contains 4 key elements. So 10, 15, 16, 17. So all the leaf nodes are linked to each other. Okay. So now after inserting 17, so this is the B plus tree we are getting. Okay. Next insert. Next element is 17 is over. Next element is insert 8. Okay. So before inserting element 8, the existing B plus tree is 20. 20 left child is 4 key elements, 10, 15, 16 and 17. Next 20 right child is 20, 30 and 40. Okay. Now, so first we have to find out the location of where we are inserting 8. 8 is compared with 20, so 8 is less than 20. So that go to the left pointer of 20, the left pointer points to a left subtree. So the left subtree contains a node that contains 4 key elements. So that is 10, 15, 16, 17. Okay, now 8 is compared with 10. Okay, it is a lesser. Now 8 can be inserted to the left of 10. Okay, so suppose 8 can be inserted at this place. Okay, how many number of nodes are there in this node? So 5 key elements. But according to the property 1, maximum number of key elements per node is equal to 4. But this node contains 5 key elements. Okay, so now this is a invalid node. Okay, to convert this invalid node into valid node, we have to perform the splitting operation. So the splitting operation can be performed at the middle node. So this node contains 5 key elements. So 5 by 2, that is equal to 2.5. 2.5 ceiling value is equal to 3. So at the third element, we have to perform the splitting operation. So now after that, this node can contain 5 key elements. So now at the middle element, we have to perform the splitting operation. Okay. So now after performing splitting operation at the middle element, that is 15, now 15 can be taken as parent. Now 15 left childs are 8 and 10 and this 15 right child are 16 and 17. This 15 can be added to the root node or its parent node. So after adding 15 to the parent node, so now the parent node contains 15 and 20. Okay, so the middle element is 15. 15 can be taken as parent. This parent node 15 can be added to its parent value 20. So after adding, so in addition to 20, 15 is also added. 15 is compared with 20. 15 is less than 20. So 15 can be inserted to the left of 20. Okay. Now 15 left child. 15 left child are 8 and 10. 15 left child contains 2 key elements, 8 and 10. 15 right child contains 16 and 17. So in addition to 16 and 17, 15 is also added. Because in the B plus tree, so the leaf nodes contains the data elements, the internal nodes contains the pointers or addresses that points to the data elements at the leaf node. Okay, so now, so this is after performing splitting at the 15, this 15 can be added to the parent. So now 15 comma 20. Now 15 left childs are 8 and 10. 15 right child are 16 and 7. In addition to 16 and 17, 15 is also added. Now at the right, 20 right is there is no change at the 20 right child. So it contains 20, 30 and 40. Okay. So all the leaf nodes are linked to each other. Okay. So after inserting 8, this is the B plus tree we are getting. Okay. Next we are inserting 4. So before inserting 4, this is the existing B plus tree. Okay. First we have to find out the location of 4 where we are inserting. Okay. 4 is compared with 15. So 4 is less than 15. So that go to the left pointer of 15. It points to a left subtree. The left subtree contains a node that contains two key elements 8 and 10. Every node contains 4 key elements maximum in the B plus tree of order 5. But this node contains how many number of key elements? 2 key elements. So there is a possibility of inserting another 2 key elements into the same node. Okay. So 4 is compared with the first key element 15 in the root node. So 4 is less than 15. Go to the left pointer. The left pointer points to a left subtree that contains the node that contains 2 key elements 8 and 10. Now 4 is compared with 8. 4 is less than 8. So that 4 can be inserted to the left of 8. Okay. So element 4 can be inserted into the same node or not? Yes. Element 4 can be inserted into the same node because so this node contains maximum of 4 key elements, but before inserting 4, this node contains only 2 key elements, so that 4 can be inserted into the same node. Now after inserting 4, this is the B plus tree we are getting. 4 is less than 8, so that 4 can be inserted before 8. So after inserting 4, this is the B plus tree we are getting. So all the leaf nodes are linked to each other. Okay. Now insert 5. So before insert 5, the existing B plus tree contains a root node. That root node contains 15 and 20 key elements, and 15 left child is so 4, 8 and 10. Next, middle child contains key elements 15 and 16 and 17, and 20 right child contains key element, so that is 20, 30 and 40. Okay. So before inserting 5, this is the existing B plus tree. Okay. First we have to find out the location of 5 where we are inserting into this existing B plus tree. First 5 is compared with the key elements at the root node. So thus root node contains 2 key elements. So first 5 is compared with the 15. It is lesser. So that go to the left pointer of 15. So it points to a left subtree. So that contains a node that contains 3 key elements. Okay. So there is a possibility of inserting another key element into this same node, because each and every node in the B plus tree of order 5 so contains maximum of 4 key elements, but this node contains only 3 key elements, so that hence there is a possibility of inserting another key element into this same node. So now 5 is compared with 4, it is greater. Next 5 is compared with 8, it is lesser. So that 5 can be inserted in the middle of 4 and 8. So 5 can be inserted into this place. Okay. So after inserting 5 into this node, now this node contains 4 key elements. This node contains 4 key elements, 4, 5, 8 and 10. Okay, so 4 key elements. Yes, it is a valid node because maximum number of key elements per node is equal to 4. Now this node contains 4 key elements. So after inserting 5, so the resultant B plus tree is the root node contains 15 and 20. 15 and 20. Now its left subtree contains a 15 left subtree contains a node that contains 4 key elements, 4, 5, 8 and 10. Next, the middle pointer points to a subtree that contains the key elements 15, 16 and 17, and the right pointer points to a subtree that contains the key elements 20, 30 and 40. So okay, all the leaf nodes are linked to each other. All the leaf nodes are linked to each other. Now after inserting all the elements that are given, so this is the final B plus tree. Check whether all the nodes are there at the leaf nodes or not. First, 4 is there, it is completed. 5 is there, it is completed. 8 is there, it is completed. 10 is there, it is completed. 15, it is completed. 16, it is completed. 17, it is completed. 20, it is completed. 30, it is completed. 40, it is completed. So all the nodes are completed. All the nodes are available at the leaf nodes only in the B plus tree. So these are the points. So this internal node, or that is root node, contains the pointers or addresses that points to the leaf nodes. 15 points to this element, 20 points to this element. This is the data element here. This is the address of 20. So this is data element. Address of 15 is here at this place. Okay. So this is in this way we have to construct the B plus tree. Okay. So thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Dippela Srinivasarao. So please watch previous videos B plus tree insertion of order 3 and order 4.